Right, so here is another example of an ionic bond between aluminum and oxygen, an oxide of the third period. We did this one in the lab where you tested the pH and realized the pH here of aluminum oxide is going to be neutral because we call aluminum oxide amphoteric. Amphoteric means it can act as both an acid and a base. But let's figure out how to do the formula for this. I'm going to do the shortcut way as opposed to how I did calcium fluoride, because now that you've labeled your periodic table with all those oxidation states, I can use those numbers in order to figure out the correct formula. So, looking at my periodic table, I know that aluminum wants to lose 3 electrons to have a full outer shell, making it a cation. Oxygen wants to gain 2 electrons in order to have a full outer shell, making it an anion. So I need to find the ratio of aluminums to oxygens so that the charges balance out to 0. Well, here's a little trick. I think about the fact that there is nothing I can multiply by 2 to make 3. But what I can do is multiply 3 times 2 together, and I can get 6. And then I say to myself, all right, 3 goes into 6 2 times, so I need 2 aluminums. 2 goes into 6 3 times, so I need 3 oxygens. And if I even make it even more simple, if I've got aluminum with a +3 charge and oxygen with a -2 charge, I can, in my brain, ignore the charges, flip the numbers, make them subscripts, Al2O3. This is going to work with most compounds as long as you don't have 4 or more electrons to give away or get. So this is how you write the formula for aluminum oxide, and I just went ahead and named this as well. Same nomenclature here. I write out aluminum, oxygen. I always stop at the second syllable, so instead of saying oxygen, I say oxide, so aluminum oxide. And hopefully this helps you write the formula and the name for an ionic compound that has an odd number of electrons.